Hi everyone, in this video we are going to discuss about how to calculate the trigonometric ratios of angles like 270 degree plus theta, where theta is an acute angle. From the concept of unit circle and trigonometric functions, we know that if we have a point P on a unit circle, then the coordinates of P would represent the cosine and sine functions. For example, the x coordinate of P would represent the cosine function of the angle theta that OP creates with the positive x-axis. And similarly, the y coordinate would be represented by the sine function of theta, where theta is the angle that OP creates with the positive x-axis. So cosine of theta represents the x coordinate, sine of theta represents the y coordinate of the point. That is the general theory of trigonometric function on unit circle. Using that concept, we are going to derive the trigonometric ratios of angles which are like 270 degree plus theta, meaning little larger than 270 degree, where theta is an acute angle. So using theta as our base acute angle, we are going to try and derive the trigonometric ratios of such angles like 270 degree plus theta, and we are going to derive the value in terms of the trigonometric ratios of our acute angle theta. So let me now plot a point Q on the unit circle where OQ would create an angle 270 degree plus theta with the positive x-axis. So let me plot the point Q. So here I have plotted the point Q on this unit circle and I have left the coordinates of the Q as blanks. However, Q being on the fourth quadrant, obviously its x coordinate will be some positive value and y coordinate would be some negative value. That's why I have left an empty parenthesis with a comma after the x coordinate as blank here, and then with a negative sign for the y coordinate. And Q is located such that OQ creates an angle of 270 degree plus theta with the positive x-axis. So now if that is the case, then you can easily imagine the angle BOQ, that little angle, would definitely be equal to theta, because total angle for three quadrants would be 270 degree and we have to go theta angle beyond the 270 degree. So that little angle, the BOQ angle, would be equal to theta. And now if you look at these two triangles, one triangle is OAP, that's a right triangle, and similarly we have another right triangle which is the OBQ. If you look at these two little right triangles, you will see that they have their hypotenuse of same length because it's the radius of this unit circle, and also they have one angle which is the theta angle that's equal between both the triangles. That means their other angle, which is the other non-right angle, right? So for example, the angle OPA or the angle OQB, those two angles would also be equal because they will be actually 90 degree minus theta. OPA will be 90 degree minus theta. Similarly, OQB will also be 90 degree minus theta. So now looks like we have two right triangles where the hypotenuse is of the same length and the corresponding adjacent angles are also of equal size. So using the angle side angle axiom, we can easily say that these two right triangles are actually congruent triangles. And if they are congruent triangles, obviously their corresponding sides all will be of equal length. So can we write it like this? So here I have noted that triangle OAP is congruent to the triangle OBQ. And also let me make a note of the corresponding sides being equal. So I have noted that OA is definitely equal to OB. Similarly, AP is definitely equal to BQ. And of course, OP and OQ will be equal because they are the radius of the same unit circle. So now let's try to calculate the cosine of 270 degree plus theta. Now if you think about the x coordinate of the point Q, the x coordinate of point Q is actually the cosine of 270 degree plus theta. So can we write it like this? Now what is the actual x coordinate of the point Q? Well, if you think about it, the x coordinate length, that length would be actually equal to the length of BQ, and that is again in the positive x-axis direction, so it will be a positive value. So we can say that this is definitely equal to the length BQ, and then up above you can see that BQ is equal to AP. So can we say that okay, this is definitely equal to AP, and also you can see that AP is actually nothing but sine of theta, or even y. AP is equal to sine of theta, which is also equal to y. So can we say okay, this must be equal to sine of theta, and also this is equal to y. So now we have found the value of cosine of 270 degree plus theta in terms of the trigonometric ratio of our acute angle theta, and that is equal to sine of theta. So now can we populate the x coordinate of the point Q? Well, x coordinate of the point Q would actually be positive y. So I am simply writing y right here. That's positive y. That is the x coordinate of this point Q. Also let me make a quick note here. Now let's think about the y coordinate of the point Q. Well, from the concept of trigonometric function on unit circle, we know that the y coordinate would be represented by the sine of the angle that OQ would make with the positive x-axis. In this case, that is 270 degree plus theta. So the y coordinate of Q would be equal to the sine of 270 degree plus theta. So let me write that down. Now what is the y coordinate of Q? Well, that would be equal to the length of OB. However, that would be in the negative y axis direction. So this will be a negative value. So we can write it as negative of the absolute value of OB. And what is OB? Well, we know that OB is equal to OA. From the two congruent triangles, we know OB is equal to OA. So we can write it as negative of absolute value of OA. And what is the OA length? Well, if we go up there, you can see that OA is actually equal to cosine of theta, which is also equal to x. So OA is cosine of theta. So let me write it down here. So this should be negative of cosine of theta. And that is also cosine of theta is equal to x. So that would be negative of x. So from here we have found the trigonometric ratio value of sine of 270 degree plus theta in terms of the trigonometric ratio of our acute angle theta, and that is actually negative of cosine of theta. And also we have found the y coordinate of the point Q, and the y coordinate is actually negative of x. So I already have a negative sign there, so I am simply writing the x right here in green color, right? So now we have filled in the blanks for the coordinates of the point Q. So now we can see that if the coordinates of P are x comma y, then the coordinates of Q would be y comma negative x. And also we see that the value of sine of 270 degree plus theta will be equal to negative of cosine of theta. So let me make a quick note. So now that we have calculated the cosine and sine of 270 degree plus theta, let's now calculate the tangent of 270 degree plus theta. We know that tangent is the ratio of sine to cos. So this will be sine of 270 degree plus theta divided by cosine of 270 degree plus theta. And what is the value of sine of 270 degree plus theta? Well, that is actually equal to negative cosine of theta. And what is the value of cosine of 270 degree plus theta? Well, that is actually positive sine of theta. So this is going to be a negative value cosine over sine, that is actually cotangent. So this will be negative cotangent of theta. So let me make a quick note. Now let's try to calculate the cosecant of 270 degree plus theta. Cosecant is the reciprocal of sine, so we can write it like this. And what is the value of sine of 270 degree plus theta? Well, that is actually equal to negative cosine of theta. So this will be a negative value, and the reciprocal of cosine is actually secant. So this will be negative secant of theta. So let me make a quick note. Now let's try to calculate the secant of 270 degree plus theta, and secant is the reciprocal of cosine, so we can write it like this. And cosine of 270 degree plus theta is actually equal to sine of theta, so we can write it as 1 divided by sine of theta. And 1 divided by sine, that is reciprocal of sine, so this should be cosecant of theta, positive cosecant of theta. So let me make a quick note. So now we are left with just the cotangent of 270 degree plus theta. So let's quickly derive that. We know that cotangent is the ratio of cosine over sine. So we can write it like this. Now what is the value of cosine of 270 degree plus theta? Well, that is actually equal to positive sine of theta. And what is the value of sine of 270 degree plus theta? Well, that is actually negative cosine of theta. So now this is going to be a negative value, but sine over cosine, that would be tangent. So this would be negative tangent of theta. So let me make a quick note. So we have been able to derive the trigonometric ratios of 270 degree plus theta in terms of the trigonometric ratio of our acute angle theta. I hope everything made sense. Thank you for watching. See you in the next video.